Okay, so this example is to do with inclined planes, in other words, slopes. So we've got a block of mass 10 kilograms sliding down a smooth slope angle at 15 degrees horizontal. We're going to draw a force diagram to show the forces, which we need to do regardless of what it said. We're going to calculate the magnitude of normal reaction of the slope on the block and then find the acceleration. Okay, so starting part A with our diagram. Let's make it nice and clear, and then that's going to make life easier for us. So we've got horizontal ground here, we've got the slope, which is 15 degrees, and we've got the block. So the block's got a mass of 10 kilograms, so I'm going to label that on there. I want to draw all the forces that are acting on this. So we've got the normal reaction force would be here. So the key thing is it's at a right angle to the slope rather than just going straight upwards. So that's what normal means. It means it's perpendicular to it. We've also got the weight of the block, which is going to be 10g, which is the mass times g. And in fact, that's it. Actually, there's no force acting, nothing's pulling on it, and there's no friction because the surface is smooth. So we can get on with calculating the different things. I suppose the only thing to add is that we expect block to be accelerating here, so I'm just labeling that there is some acceleration there. Okay, so part B, calculate the magnitude of the normal reaction. So what I want to do is resolve perpendicular to the block slope rather. So it's going to be easier to do this than trying to go horizontally or vertically, because we're in all sorts of weird components to forces. So resolve perpendicular to the surface. So R is already perpendicular to the surface. That's kind of the whole point of it, really, isn't it? But we need to then split the 10g force, the weight, into components that are perpendicular to the surface, which is this bit, and parallel to the surface, which is the bit here. Okay, so that bit is going to be 10g times something. Well, this angle here is actually 15 degrees. So you can do a little bit of geometry and figure that out if you wish, because we'd have a right angle here. This angle would then be 65 in a triangle, so 85 rather, 75 even in a triangle. And so because this is a right angle, we'll have 15 here again. In fact, this angle, when we're doing these kind of questions, is always the same as the angle in the slope, so you can write it straight down. Okay, so the component here, perpendicular to the slope, is 10g times cos 15 because it's adjacent, and then this one's 10g sine 15 because it's opposite. So if we resolve perpendicular to the surface, r subtract 10g cos 15 is equal to 0. So in other words, r is equal to 10g cos 15. And then we can calculate that to be r is 94.7 newtons. I'm just going to leave my calculator display with that number on. I just want to leave that on because I'm going to be using that number later. So if you leave that on, then it means you're not going to lose your accuracy. Okay, so to get the acceleration, we're going to resolve parallel to the plane. So if we treat the acceleration going down as being the positive direction and use F equals ma, then there's only one force which is actually parallel to the slope, to the plane, which is the component here, this 10g sine 15. So these two forces, they're perpendicular to the plane, they're not going to cause the acceleration, it's just this one. So we've got 10g sine 15 is equal to the mass, which is 10 times the acceleration. And so the acceleration is just g times sine 15, and we can just calculate that. And from there I get that the acceleration is 2.54 meters per second squared, and that's actually us done.